All right, last question. I almost didn't video it because I think you should be getting more comfortable with this. I don't think these should prove to be a huge challenge at this point, but there's a couple little things to point out, so I wanted to make sure that was clear. Especially because this is with a graph instead of a table, so I don't know, whatever. But part A, find a second degree Taylor polynomial for h of x. So we have this function for h of x. So if I'm going to write my Taylor series, I need h and its derivatives. I need all the way up to the second derivative because I want a second degree. So this is just like the last problem. There's nothing different here. So you can go ahead and look at the last problem. And here's h of x. Here's h prime. Derivative of x is 1. Derivative of 2 is 0. Derivative of this is Leibniz law. Plug in the 2x multiplied by 2. Take the derivative again to find the second derivative. Derivative of 1 is 0. This 2 is really in front. Derivative is 2 times the derivative of g. Chain on the derivative of 2x. Evaluate all these things at 1 because I'm centered at 1. Get -1, -1, -12. Put them all into the Taylor and reduce. So part A now at this point is hopefully pretty easy. So part B, is which was the one that was a little bit weird. Explain why this polynomial could not be the second degree Taylor polynomial for g of x centered at x equals 2. So I was trying to write out, well, if I was writing the series for g of x, I would need g of 2, g prime of 2, g double prime of 2. Well, the polynomial they're giving me is this. So I need to see, like, where's the crack? Like, where's the hole that this information is not going to match this? So if I were writing the series for g of x centered at 2, I would need g of 2, which if I go to the graph, g of 2 is right here, it's 1. I would need the first derivative of g. So go over here. If this is the graph of g, I would need the first derivative of g at 2. So I don't have the derivative, but I do have the slope of I do have the picture of the tangent line, the graph of the tangent line. So the slope of this tangent line is the derivative of g. So up 3 over 1 is the slope of that line. So the first derivative of g is 3. And then what's the second derivative of g? Well, I have g, I have its tangent line here at 2, but that's all that I have. So the second derivative of g, the only thing I know is that right here when x is 2, the graph of g is concave up. So all I know for sure is that the second derivative needs to be positive. I don't know what number it should be, but I know it should be something positive. Well, if I look at what the polynomial is that they're giving me, and they're asking me, is this polynomial, could this be what the series is for g? The first term, yep. The second term, yep. But the third term, they have this as negative, but I know my second derivative has to be something positive. So therefore, nope, the series for g of x at x equals 2 cannot match this series that they're giving me. Okay, last question. Consider this series where the first 3 terms of a sub n correspond to the first 3 terms for this, which is what we did in part A. Find that when x equals 0. So if they're again asking me to find this, there's a kind of assumption there that this is going to be geometric. That's the only way I can find the value of a series, is if that series is geometric, which looks like with an exclamation, with the factorial there, how is that going to be geometric? Well, let's just trust it and let's get the first couple of terms. I know a sub n is the first 3 terms of the series from up here. So I'm going to use those first 3 terms and divide each one by 2n factorial. So, let's see. Okay, my first 3 terms are here in pink. I'm going to be dividing each one by 2n factorial. So -1 gets divided by 2 times 0 factorial because I start with 0. My second term gets divided by 2 times 1 factorial because I'm going next with n equals 1. My third term is taking this and dividing by 2 times 2 factorial because now I'm on my second term. So here are the terms of this new series that they had me write, and they want me to find the sum of this. Well, let me reduce this to 0 factorial, 2 factorial, and 4 factorial. And then they also said, find this when x equals 0. So now I have this series, and I know that x should be 0 for it. So I'm going to plug 0 in for my x's and reduce again. And what I end up with is negative a half. This becomes plus 1 over 2. Oh, P.S. Remember, 0 factorial equals 1 by definition. So I get negative 1. This becomes a half. This becomes negative a fourth. That's all I have, but it's enough to see that this is geometric. My first term is negative 1. My multiplier is negative 1/2. This is less than 1, so we're all good. We converge. The sum is going to be a over 1 minus r. Negative 1 over 1 minus negative a half. Reduce. Boom, there's my answer. Yay! All right, you should feel pretty good with series at this point. And we'll be ready to move on to kind of a more overall broad review for our next class.